A very good day, Dr. Dirman. My name is Ishwajit Singh, matrix card number CE200095, and today I'll be explaining about the lab activity of Power Lab 1, which is open loop position control. So based on this instruction, I will be demonstrating on how to do it on MATLAB. So first, we need to construct the block diagram in figure 3.4 using MATLAB Simulink. Construct this. I've already constructed it. Alright, so this is the block diagram. Just be putting the value as 0 for now, and actuator gain as 0. Okay, this is the block diagram. And then what we need to do is number 2, key in all parameter value into the Simulink block. So based on these values, I have already key in the input values. Okay, so this will be 0, this is 0.61111. the actuator gain for now is 0. The electrical part over here will be 1 divided by 0.21 s plus with 11.2. Alright, so same goes for the mechanical part, and this is the integrator, and that's all. Next will be checking the block Simulink by key in input angle value is 1 and attenuator gain value is 1 to see if the input voltage and shaft motor position display show the value. It means block diagram is function. So what we need to do is check the functionality. How do we do that? Change this input angle to 1, and then the attenuator gain to 1, and then we run it. Okay, since there is value over here and there is value over here, this block diagram is functionable. Now the next step would be increase step by step value of input angle from 0 until 10 and set attenuator gain 0. Observe the shaft motor position display and what happens to the system. Alright, so what we need to do is this input angle over here, we'll be increasing it from 0 up until 10. Alright, while the attenuator gain is constant at 0. So we're just going to see what happens to the input voltage and the shaft motor position. Running the simulation, we get everything. The input voltage will be 0 and shaft motor position is 0. Then we change the input angle to 1. Run it again. We see there's no change in the shaft motor position, but the input voltage increases. Alright, and then we keep on doing the same steps up until input angle of 10. Alright, so for 2 it was 1.222. For input angle 3 it is 1.833. Continuing it to 4, input angle 4 is 2.414. Input angle 5 is 3.056. Input angle 6, you'll be getting 3.667. Input angle 7, you'll be getting 4.278. And then for input angle 8, run it at 4.889. Input angle 9, 5.5. As for the last one, input angle 10, we'll be getting 6.111. So that's all. Now what we need to do is step number 5, which is increase step by step value of attenuator gain from 0 until 10 while set input angle 0. Alright, so earlier what we did is we set attenuator gain as the constant. Now we need to set the input angle as constant 0 while we change the attenuator gain. So attenuator gain 1, there's no change in both input voltage and shaft motor. 2, there's no change, and it will remain the same up until 10 since there's no input voltage. Alright, so I'll just be showing everything. 4, gain 5, gain 6, gain 7, gain 8, gain 9, last one gain 10. Alright, so now step number 6, set input angle 5, 10 and 360 according to the potentiometer, clockwise or anti-clockwise. Alright, and the attenuated gain would be 1, 1, 5, 5 and 88. Now I'll show you on how to do it. Input angle was 5 and the attenuated gain for input angle 5 was 1. Therefore, run it, and this is the value that we get, 3.056 for the input voltage, and the shaft position would be at 58.64. This is the clockwise, and for the anti-clockwise, put the input angle as -5. Run the simulation, I'll be getting the values in the negative value, which is -3.056, -58.64. Then change it to 10, and the attenuated gain was 5. On the simulation, these are the value of voltage and motor shaft position. Change the input angle to -10. This is the value for shaft motor position. And then we continue to do 360 input angle. For the attenuated gain is 8. On the simulation, input voltage is 220, while the shaft motor position shows 3.378 E. Alright, E04. And then we do it at -360 for the anti-clockwise and run the system. We're getting input voltage -220 and the shaft motor position is -3.378 E04. So that's all from me. Now my teammate will continue his activity too. Thank you.
I'm Benjamin Hu Haoxian, no matrix C210053. So I would like to explain about the activity 2. For question 1, is going to do the block diagram in the MATLAB. So for question 2 is key in the value inside, and question 3 is about 1, key in constant in 1 and gain in 1. And we get input voltage 0.6, output voltage 0.4, and shaft motor 0.78. So for question 4 is added the constant from 0 until 10. So for 0 we run, the value is 0 at the display. We change one value, run and get 0.6, and here is 0. And the value become 1.2, and here also constant 0. Run, and the value will become 1.8, and here also 0. To 4 for the constant, value will become 2.4, and here is 0. Change to 5. The value will become 3.0, and here is 0. X, run, the value will become 3.6, and here also 0. Constant change to 7, value become 4.2, here also 0. Change to 8, and 4.8, and here also 0. Change to 9, it becomes 5.5 and 0, and lastly is change to 10. So the value is 6.1 and 0. So for activity 5, the constant value will become 0, and we start adding the gain from 0 until 10. So first is 0, the value 0, 0, which is 1, the value also 0, 2, So 0, change to 3. Same as 0, change to 4, is also 0. 5, so 0, change to 6. Run, and also get 0. Change to 7, is also 0. Change to 8. Display also 0 also. Change to 9. Display value also 0. And lastly, change to 10. Run it. And also 0. For question 6, the input is for the first table is input is clockwise, so it's positive, and gain is 1, so we run it and get a value 3 for input voltage, 2.4 for output voltage, and 3.9 is shaft motor position. So for next anti-clockwise, and the gain is still 1. For anti-clockwise, we change the value to negative. So all the value will become negative. Input voltage is negative 3.0 and negative 2.4 for output, negative 3.9 for shaft motor position. And next, we change the angle to 150 for clockwise. And gain is about 5. And get a 91 value for input, 84 for output. Shaft motor is 138. So next is anti-clockwise, so we put in front of negative. Again also 5. So we get a value, all the value is negative, negative 91, negative 84, and negative 138. For next angle, we change to 360. Gain is about 8. Right. And input voltage is 220. Output voltage is 190. Shaft motor position is 311. So for next that is anti-clockwise. So we change to negative. Gain is still the same. So the value all is become negative. Negative 220, negative 190, and negative 311. That's all for me. Thank you.